All right, so now we're taking a look at day 9 homework. It says that this graph of f of x consists of a square root function, right, which is normally like this, and an absolute value function, which is normally like this. We're going to write the equation of f of x below. So when you read the graph, you read it from left to right. So really what we have here is the square root function first. So let's establish that there is a beginning point or an end point, like right here. You are looking for the next spot where it's 1 away. And so in this case, I can see that we are going to reflect the y-axis because this is the parent. So notice that if you have the square root of negative x, it's going to go like this. And that's what's happening here. So we know that we have a negative x. We also have this spot shifted 4 to the left. So we have to be very careful about what that looks like, especially when we have a negative x involved. So we know that we've got a negative 1, and then we have an x plus 4 because that represents 4 units left. Okay, so when we go to simplify this and we distribute the negative, we've got a negative 1x minus 4. So our equation is going to just be the square root of negative x minus 4 because it's going this direction. And then if we take a look at our vertical shift, we went up 5 units. So that plus 5 is going to be on the outside of that radical. And then the domain for this, notice that it works from negative 8, but not including negative 4. So we could go negative 8, it includes negative 8, so we have the equal to, and it does not include the negative 4 because it's open. Now we can easily identify my absolute value. The vertex is right here, and it looks like it has a slope of 1. So that's just simply going to be the absolute value. 1 unit left is going to be x plus 1. And then we are up 2. And then now the domain is going to be from negative 4, not including negative 4. And it goes all the way to positive 4, not including because of the open. So based on the graph, complete the following statements. As x approaches negative 4 from the left, so we are on the left side of negative 4, what is the y value that we are approaching? The y value we are getting closer to is 5. And then when we approach negative 4 from the right side of negative 4 is right here, which means we're on this function. The y value that we are approaching is 5. Using your equation from number 1 above, determine if f of x is continuous at negative 4. If it's not, classify the discontinuity and justify, then check the graph to verify your analysis. Well, first, I'm looking at the graph and I recognize that it's point discontinuity. So let's just make sure that when we go through this, that our answer represents that. All right, so the first thing you need to do when you're classifying discontinuity is where you are, where the point is that we are unsure about, which is this point right here, when x is negative 4, we have to look to the left and to the right. So we're going to say as x approaches negative 4 from the left, f of x, and remember it says using my equation. So I need to plug it in my equation. So in the equation, when on the left side, which would be this one, negative 4 minus 4 plus 5. That's going to give me the square root of 0 plus 5, and it equals 5. I'm going to do the same thing as x approaches negative 4 from the right side, but the equation on the right side is going to be the absolute value. Negative 4 plus 1 is negative 3. The absolute value of negative 3 is 3 plus 2 is 5. So the fact that it's not defined at negative 4. So f of x has a point discontinuity at x equals negative 4. Always classify where that is, because both pieces approach the same y value, but f of negative 4 equals undefined. Okay, or you can even say f of negative 4 does not equal the same y value. Okay, so the domain of f of x, if we look at this, we are going to go from negative 8. We stop at negative 4 because it's undefined. We pick back up on the other side of negative 4 and we go all the way to positive 4. Range, the smallest y value is 2. It includes 2. Even the y value of 5, which is not included here, it is included on this one. The y value of 7 is not included on this open circle, but it is included here. So we have brackets around 2 and 7. All right, so here we go. The graph of g of x consists of an absolute value function and a square root. Write the equation. So we've got g of x. The first one we see when we read the graph from left to right is an absolute value. Notice that it's going down. Notice that the slope is 1. So then I don't have another value on the outside of the absolute value. So this is, the vertex is 3 to the left and up 4. And the domain is from negative 5, not including, because it's open. And it closes at negative 1. So we are including negative 1. Now, this square root, if we notice, there's the point right here that's right next to it. Now, it is reflected across the x-axis because it's doing this thing. So that represents a negative on the outside. So we are going to have a negative on the outside. Then we have the beginning point moved to the left. So we're going to have x plus 1, and then it moved up 1. And since this goes on forever, it is simply just x is greater than, not equal to, because it's open, negative 1. Now we're going to complete these statements. As x approaches negative 1 from the left, which means we're on the absolute value, the y value that we are getting to is 2. As we approach negative 1 on the right side of negative 1, the y value is 1. So we can look and see that these don't match, which means we have a jump discontinuity. But it says use our equation from number 5 to determine if it's continuous at negative 1. If it's not, classify the discontinuity and justify your answer. Check our graph. All right, so again, we look at the left. And we're using our equation, which means I'm plugging it into this equation. So instead of putting x, I'm going to put negative 1 plus 3 plus 4. And what does that give me? It gives me the negative absolute value of 2 plus 4. This gives me negative 2 plus 4 is 2. We're going to go as x approaches negative 1 from the right. G of x in this equation is negative 1 plus 1, and plus 1 is on the outside, which gives me negative absolute value of 0 plus 1, which equals 1. So g of x has jump discontinuity at x equals negative 1 because both pieces approach different y values. Okay, so as soon as they approach different y values, it doesn't even matter if one's defined or not. All right, domain of g of x, we begin with an open circle at -5. -1 is closed, so x equals -1 is in the domain, and then it goes on to infinity. The range negative infinity, and then it stops when y is 1. It doesn't include that because it's open. Picks back up and includes 2, so I'm going to use brackets. And the highest y value is 4, and it also includes 4.